Faster, smarter search with BM25 plus Embeddings Rerank. By the end, you will build a simple hybrid search pipeline. You will see BM25 find candidates quickly. You will see sentence embeddings reorder those candidates for better relevance. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Hybrid search boosts both precision and recall. BM25 optimizes term relevance by ranking documents that share query words and rewarding rare words with higher scores. Sentence embeddings map full sentences into vectors, so semantic matches survive when words differ. The trade-off is obvious. Exact term searches are fast and cheap, while embeddings need more memory and CPU. Hybrid gives you the best of both worlds for medium-sized collections. Hybrid search shines when queries are short and documents vary in style. It finds exact term matches first, then corrects subtle semantic misses with re-ranking. One limitation is latency at query time, if you do heavy embedding computation or exhaustive vector comparisons. Now we will build a tiny example and inspect basic stats before we retrieve. This snippet builds a tiny text corpus and reports compact corpus statistics. It creates a few example documents, so we have a stable dataset to work with. The code token prepares document text, token counts, and simple length summaries, so you know document size distribution and vocabulary size. Those numbers matter because BM25 uses document length normalization and IDF uses collection frequencies. If you change corpus size, you will see IDF values shift and BM25 scores redistribute. Keep the corpus consistent while you experiment so score changes are due to algorithm tweaks, not data noise. Now we will run a simple term frequency search to see raw matching. This snippet runs a basic term frequency search and returns top document indexes. It counts how often query words appear in each document and sorts documents by that raw count. That shows the baseline. Documents with more matching words surface first. The snippet also demonstrates how stop words and common words flood results because they boost counts without adding meaning. If you change the number of top results returned, you widen or narrow the candidate pool for later re-ranking. Increasing candidates gives embeddings more to reorder, but costs more compute. Use a small candidate set for low latency and a larger one when accuracy matters. Next, we will weight terms by rarity using TF-IDF. This snippet upgrades scoring to TF-IDF to weight rare query terms higher. TF-IDF stands for Term Frequency Inverse Document Frequency, where inverse document frequency measures how uncommon a term is across the whole corpus. The code computes TF-IDF vectors for documents and the query, then scores documents by the dot product between those vectors. That punishes common words and emphasizes distinguishing words. If you adjust the IDF smoothing or the n-gram range, you influence sensitivity to rare phrases. More smoothing reduces extreme boosts for very rare tokens, but might lose signal from distinctive words. Next, we will switch to a retrieval formula tuned for information retrieval, BM25. This snippet applies BM25 retrieval with IDF and length normalization. BM25 is a ranking function that combines term frequency, document frequency, and document length control to produce more stable scores than raw TF-IDF. The snippet computes per term contributions and sums them to score each document. BM25 exposes two knobs typically called K1 and B. Increasing K1 reduces saturation, so high term counts scale more. Lowering it causes faster saturation. Increasing B makes length normalization stronger, penalizing long documents more. Tuning those two values changes how much long documents or repeated terms dominate results. Now we will combine BM25 retrieval with vector re-ranking by embeddings. This snippet performs hybrid re-ranking. BM25 retrieves and embeddings reorder. It first uses BM25 to cheaply fetch top candidates. Then it computes sentence embeddings for the query and for each candidate and scores them with cosine similarity, which measures the angle between two vectors to capture semantic similarity. The snippet replaces BM25 ordering with a blended or pure embedding order depending on your chosen strategy. If you increase the candidate pool size, embeddings get more to compare, and recall improves at the cost of latency. If you lower it, you speed up queries, but risk missing semantically relevant documents that BM25 did not surface. Recap. Hybrid search uses BM25 for fast, term-based candidate retrieval and sentence embeddings for semantic re-ranking. Use it when you need robust relevance with reasonable latency on medium corpora. One caveat is extra compute and memory for embeddings, and the choice of candidate pool size can strongly affect both cost and quality. Next step, try tuning BM25, K1 and B while varying the candidate set size and measuring retrieval quality with NDCG, which is a ranked relevance metric that tells you how well your re-ranker orders results. If Practical IR helps your projects, subscribe and watch the rest of the search videos for hands-on demos and tuning tips.